The product moment correlation coefficient measures the strength and direction of a linear relationship between two variables. The least squares regression line is the line that minimizes the sum of the squared vertical distances from every data point to the line. Here is a worked example. 4 data points record the incline angle of a ramp and the time taken for an object to slide down it. The angle values are 10 degrees, 20 degrees, 30 degrees, and 40 degrees. The corresponding time values are 7.5 seconds, 5.5 seconds, 4.0 seconds, and 2.0 seconds. Picture these 4 points plotted in 2 dimensions, with angle along the horizontal axis and time up the vertical axis. Now picture the same points tilted into 3 dimensions, where each vertical gap between a point and a trial line is shown as a small shaded square standing up from the graph, so that its area represents the squared distance being minimized. Step 1. Compute the necessary sums. There are 4 data points, so n equals 4. The sum of the angle values, called sum x, equals 100. The sum of the time values, called sum y, equals 19. The sum of each angle multiplied by its matching time, called sum xy, equals 385. The sum of each angle squared, called sum x squared, equals 3000. Step 2. Find the gradient, called b. In words, the gradient equals n times sum xy minus sum x times sum y, all divided by n times sum x squared minus the square of sum x. Putting in the numbers, the top part equals 4 times 385 minus 100 times 19. 4 times 385 equals 1540, and 100 times 19 equals 1900, so the top part equals 1540 minus 1900, which equals negative 360. The bottom part equals 4 times 3000 minus 100 squared. 4 times 3000 equals 12,000, and 100 squared equals 10,000, so the bottom part equals 12,000 minus 10,000, which equals 2,000. So b equals negative 360 divided by 2,000, which equals negative 0.18. Step 3. Find the intercept, called a. In words, the intercept equals the sum of y minus b times the sum of x, all divided by n. Putting in the numbers, a equals 19 minus negative 0.18 times 100, all divided by 4. Negative 0.18 times 100 equals negative 18, and 19 minus negative 18 equals 37. So a equals 37 divided by 4, which equals 9.25. Step 4. State the regression line. In words, the predicted time equals the intercept plus the gradient times the angle. In symbols, t equals 9.25 plus negative 0.18 times theta. Look again at the 2-dimensional graph, now with this line drawn through the scattered points. In the 3-dimensional view, the same line becomes a tilted flat sheet, and the small squares from before sit snugly between each point and that sheet, showing how the line was chosen to make the total of those squared gaps as small as possible. Check step. Substitute an angle of 30 degrees into the line, giving predicted time equals 9.25 plus negative 0.18 times 30, which equals 9.25 minus 5.4, so predicted time equals 3.85 seconds. The actual recorded time at 30 degrees was 4.0 seconds, so the prediction is close, confirming the line fits well. The gradient is negative, and the data does indeed show time decreasing as angle increases, so the sign of B matches the visible trend, confirming the answer.